It's time to move on to the next section, stepping towards object-oriented programming. Now let's begin with a simple Hello World program. In this program, I have a method public static void main with string args. This is the method from where the program execution begins. The method prints the message Hello World. The points that you need to remember here are that you can have only one program initializer method, similar to your language C, that is public static void main. A class is similar to a structure in C. In addition to a C structure, the class also includes methods. Further, all methods in Java are a part of some class. This implies that you cannot have methods which are not a part of any class. All Java programs or classes are written in a file with an extension of .java. To compile the Java program, move to the folder where you have saved the source file and type the command javac followed by the source file name, as you see here in this piece of code. javac hellojava.java, and then to run, type the command java followed by the class name, as you see here, java hellojava. Another important point that you need to remember is that the class name which is followed by the command java has to have the public static void main. Now let's talk a little about object-oriented programming concepts. We will first talk about the three major components of object-oriented programming, and then we will talk about the four important features of object-oriented programming, that is encapsulation, abstraction, generalization, and polymorphism. Class. All objects have state and behavior, that is, a particular structure which is defined by a class. For example, if I have to build a house, then I first need the blueprint of an house. Here, the blueprint is what is defining the structure of the house, and hence can be considered as a class. And then the house itself is an object, as it needs to exist in the real world. Class is also known as the blueprint of an object. State is shown by the values held by variables in a class. This implies that a state refers to the current condition or circumstance of an object, and this state is determined by the values held by variables in a class. We know that every object in real world has its own set of behaviors, and these behaviors are represented as methods in object-oriented programming language. Object. As discussed, all objects are real-world entities, and they have two things in common: state and behavior. For example, all men have state. Name, color, height, weight determine the state of a given person, and behaviors such as run, eat, sleep, and so on. Cars also have a state and behavior, such as current gear, current speed, number of gears determine the state, and accelerate, slow down, change gear, which determine the behavior. Behaviors are represented as verb phases. They represent the actions that an object can perform. Class and object. As discussed, class is a blueprint of an object. Here is a blueprint of an house. And here is the object in the form of a house. Here is an example of a class. Here, class is a keyword and cat is the name of the class having variable, speed and methods move and stop. As discussed, methods represent the behaviors of the class, and variables are used to hold the state of the class. Example of an object. An object is an instance of a class. It provides the physical existence to the variables declared in the class. The new operator dynamically allocates memory for an object and returns a reference. Here, Tom is an instance of class cat. Tom refers to an object. Let's talk a little about the parts of an object. Properties. The properties of an object determine the state of an object. State. State refers to the current condition of an object. Methods. Methods determine the behavior of an object and they reset the properties to affect the state of an object. For example, the method accelerate of a class car would reset the value of the property speed. Constructors. Constructors are much like methods without a written type. They are automatically called after the object is created. Constructors are used to initialize the object. Constructors cannot be called like methods. They are implicitly called by the JVM. Destructors. Destructors are just opposite to constructors. They are implicitly called by the JVM before the object is garbage collected. They are used for deallocating or dereferencing the resources held by the object. How are properties and states related? The values set to the properties determine the state of an object. For example, let's consider three properties of an object Tom: chasing, driving, and sleeping. All these properties can be set a value of true or false. If I set the value true to chasing, it implies that Tom is chasing, and chasing becomes the state of Tom. And if driving is set to true, it implies that Tom is driving, and driving becomes the state of Tom. And if sleeping is set to true, it implies that Tom is sleeping, and sleeping becomes the state of Tom. This is how properties and state are related. Methods. An object behavior needs different access rights, as some behaviors are private to the object and should be only available to the object itself. I will explain this in detail when I discuss about Java access modifiers. Abstraction. Abstraction is an important feature of object-oriented programming. Abstraction is a process which focuses on how to use than how it works. For example, I need not know how the car or bike works. I just need to know how to use them. That is, how to change the gear, how to accelerate, how to stop, how to turn these vehicles. Encapsulation. Encapsulation is another important feature of object-oriented programming. In short, encapsulation is the mechanism that binds together code and the data it manipulates. Stepping towards OOPS. In this section, I will first show you an implementation of a car and its driver in a structured programming language. And then we will implement the same in an object-oriented programming language such as Java. In this example, I have created a structure called car in which I have defined two data members, gear and speed. In our object-oriented terminology, we may call them as properties. Here is the structure. And I have defined four methods which in our object-oriented terminology are called as behaviors. As discussed earlier, the methods change or could change the values of the properties and thus result in the change of a state. Here, an incrementation to the gear or an incrementation to the speed might change the state of the car. Imagine a project with 100 structures and over 1,000 functions. It would be extremely difficult to track which function or functions are referring to which structure. Any modification to such an application can easily produce an unwanted result. However, good documentation standards can prevent such problems. And now I want you to work on the example from your Java Virtual Guru referring number 1.1.1. I hope all of you are done with the example. Now let's see the Java implementation of the same. In this example, I have replaced the structure car with the class car. The difference, if you have noted, is that the structure only holds the data members, whereas the class also holds the member methods, as explained in encapsulation. This is the entire structure of the car. Here, gear and speed are referred as properties of car. And increase gear, decrease gear, increase speed and decrease speed are referred as methods or behaviors of the car. In this example, I have also created another class called driver. Where I have implemented the public static void main This is the method which acts as the program initializer, the point from where the program execution begins. Here, at this line number 29, I am creating an object of a car, saying car1 is equal to new of car. And then I am calling the increase gear method. Once I call the increase gear method, the control moves to the increase gear method inside the car class. The control comes right here. It checks if the gear is less than or equal to 3. If it is so, then it increments the gear by 1. Now once we come back to the main method, immediately after the increase gear method, we're calling the show gear method, that is car1.showGear. Here, the control once again moves to the show gear method. and then it prints the current gear value. It prints it as car is now in gear plus the gear number, plus here is used for concatenation. The output can be seen on your screen, which would look something like what I have highlighted here. And then further it goes and calls increase speed, and then it goes and calls show speed, and then you can see the output of the speed here down below. And subsequently you may call the different behaviors of the car and change the state of the car, and here print the state of the car. And now you may work on the example reference number 1.1.2 from your Java Virtual Guru. I hope you appreciate the example. Now let's see a more appropriate way of implementing the car and driver example. Car and driver share an association relationship. Now let us see how to implement an association relationship in Java. For more information on association, I suggest you to read any object-oriented design and analysis book. In this example, I have not changed the car class. What I had done is that instead of calling the car methods directly from the program initializer, that is the public static void main, I had used the driver class methods to do the same. This is the previous example where we have been directly calling the methods of the car from the public static void main. Now this has been replaced with the driver class starting here from line number 28, which has appropriate methods to interact with the car class. So what I had done in the program initializer now is that I had created the car and the driver objects, and then I had called the driver members or the driver methods in order to interact with the car. This is the right way of implementing the association relationship, that is, the relation between the car and driver.